Okay, I think we're good to get started. Welcome everybody to another Ignition community meeting. Today we're going to have two presentations, one from an external contributor, Alison Taxton. We'll be talking about the differences between Ignition Gazebo and Gazebo Classic that she observed. So looking forward to that. And another one is going to be from Ian Chen at Open Robotics, talking about the Ignition rendering library. So two very interesting presentations coming up. Before we get into that, I just want to ask that everyone add your names to the attendees list. And I'll go over some announcements. Then we're going to have their presentations. We're going to go over some news that Kat curated for us. And as I always mention, everyone is welcome to add items to the agenda here below for us to talk about when we have time at the end of the meeting. So without further ado, let's get into the announcements. So one thing that I had to announce for you guys today here is that we're approaching the release of our next LTS, which is going to be Ignition Fortress. So I have a timeline here for everybody to be aware. Fortress is going to be the second LTS after Citadel. Citadel is our current LTS that is supported for 5 years. Fortress is going to be supported for 5 years as well. So we're going to be doing a feature freeze on September 7th, which is a Tuesday, and feature freeze is going to last 2 weeks, which means that no new features can be targeted at Fortress, but all pull requests that are open with new features targeted at Fortress can still be merged. Then when we get to code freeze on the 21st, then we are not going to be merging any new features. Only critical bug fixes can be merged into all of the libraries. Then on the 22nd, the day after, we start the tutorial party like we always do with the help of the community. It was very nice last time that we had for the Edifice release, a lot of help from the community. People got t-shirts. So we're going to do something similar this time, a whole week for people to help us review all of the tutorials, make sure that the release is working with the nightly builds and everything. And then on the 29th, one day before the actual release, we're going to be doing another community meeting like this one, also on the last Wednesday of a month, last Wednesday of September in this case, where we're going to be doing a lot of demos of the new features that are coming up in the release. And finally, if everything is good, the release is going to come out on the 30th. It could be that we find critical bugs during the tutorial party or during code freeze that delay these dates, but usually we get to iron those out right before the release, and the release comes out in time. So does anyone have any questions about the release or anything like that? Otherwise, we can just jump right into the presentations. No? Okay. So let's start with our first presentation. I see Alison is here already. Thank you, Alison, for participating in the meeting. Alison has been putting together a lot of blog posts comparing Ignition Gazebo and Gazebo Classic. So we're looking forward to listening to what she has to show to us today. So Alison, you can share your screen whenever you're ready.
Yeah, hi, sure. Share screen. There you go. Get to see yourselves, just kidding. Hi, everyone. I'm Allison. So I had been looking at Ignition versus Gazebo. I actually started looking at this back in Ignition Citadel. I know it's moved on quite a bit from then. But the main things I wanted to know is like, how does it perform compared to the classic Gazebo, and also like how hard is it to like switch from classic Gazebo SDFs to use Ignition. So I put together a series of like very simple physics like experiments just to see what the relative performance was and like what things worked and what all the settings kind of did. So the first thing I looked at is a very simple thing of inertia and like how does inertia work in both of them, and they both work exactly the same, which was great. So it was kind of like, okay, the hello world of simulation passed, yay! And so during the putting this together, like I found a couple of things out. One was that I couldn't reuse the exact same SDF for the classic Gazebo for Ignition. I had to put in, at the time anyway, I had to put in a whole bunch of extra different parameters for visualization. Since the visualization of ignition is like more component based, you had to set all of the like different components that you wanted, like basically in the SDF, and say like what plugins you wanted loaded and all of that. And whereas all of that kind of came like with Gazebo Classic. So I used Zacro and like made a little include script in order to use the same exact physics setup, but with this like different implementation for the GUI display. So that was one of the first difference. The second difference I noticed was how things were rendering on my screen versus in Classic Gazebo versus in Ignition. And I know that the Ignition system has a different visual renderer. And so it was just kind of interesting to see like how the same models would like show up in both. I don't know if my screen is like big enough. Should I zoom in here? Oops.
I think it looks good.
Okay. Okay. And then, so the next thing I looked at, passes inertia. The next thing I started looking at was friction, and how the different friction components in SDF kind of worked. And so I created a script where it sets kind of the different friction parameters. So like this first cube, I was like, well, the specification says that if no friction is set, mu1 and mu2 are set to like very high friction, and therefore the cube shouldn't move. And then I started moving that around. So like mu1 and cube 2, mu1 is high friction, but mu2 is 0. And so I kind of gave my expectations with this. According to the SDF, it should be set to the world frame. On Classic Gazebo, it ends up sliding down the ramp. This ramp is aligned with the x-axis, and I guess I initially just assumed that the x-axis would be where the friction plane was aligned with as well, but it's actually rotated 90 degrees. So like mu1 and mu2 are in the world frame. Mu is aligned with the y-axis, and mu2 is aligned with the x-axis, which was just a little bit interesting. But more or less performed how I expected, except for that rotation. The same thing with the next ones, where I was actually messing with the friction direction to see like how the friction direction would affect the simulation. And Classic Gazebo did exactly what I thought it would do. You set it pointing down the ramp, then the box doesn't move. You set it pointing perpendicular to the ramp, and it slides down. So everything here kind of lined up with my expectations. And then it's some different permutations along those lines. And then some just like rotations of like, instead of messing with the mu values, messing with like the rotation of the cube. And so let's see, cube.
Right now the stress group's not doing anything at all, right?
Cube 6 was rotated, and yeah. So that was the first one. It kind of more or less aligned with what I expected. And then so I did the same thing in Ignition. And it did not do exactly what I thought it would do. The X and Y axes are aligned to where I thought they would be for the world frame. So the mu1 was aligned with the x-axis, and mu2 was aligned with the y-axis. But the blocks, some of the other blocks, not like with the F direction, did not go down the plane like they were before. And so that was an interesting thing. I wanted to make sure that like the mu1 and mu0 and mu2 values were aligned as I thought they were. And so I did this other little experiment that was just like, let's just put a whole bunch of boxes on a whole bunch of ramps and have them all be the same, and like see what that does to the modeling of friction, since it is kind of aligned with the world frame. And it does do this, it has a pyramid friction pyramid representation. So you kind of expect it to create a square. And you can tell if you make one of them, if you make mu1 larger, it goes along with the y-axis. You make mu2 larger, it slips more along the y-axis. So you can see that they're different in classic Gazebo versus ignition. And so that was sort of the first round of things that I looked at. And then I was like, well, what does bounce do? Because bounce is one of those parameters that I think is a little bit difficult for simulators to model. Some of the things that I had to do to set up bounce is not wholly intuitive. So the first thing was setting the restitution coefficient, in which I had to set both on the ball and on the world, on the ground plane. And then a threshold, which is the penetration. The penetration threshold needed to apply the restitution force, and then like the max velocity that you kind of allow the bounce to produce. So like I said, it was only like the infinite bounce, the one that just you expect if you have like full restitution coefficients and you leave your thresholds pretty low and your max velocity pretty high, you expect it to like just bounce forever. And the only way that I was able to do that was if the ground was also had the restitution coefficient set to 1. So the two surfaces like interact with each other in that way. But of course the ground doesn't move, so that I put the max velocity on that to 0. And so that actually was able to achieve pretty good bounce. But at the time, I think Citadel did not apply the bounce, any of the restitution coefficients into its physics simulator. And so when I tried it in Ignition, all the balls just dropped and there was no bounce at all, which was kind of funny to see. I think that, right, I simulated this more recently, and it seems like this is actually fixed. So the bouncing is capable to, bouncing does work in Ignition now, which is great. And then I did a couple of different experiments with joint dynamics, most of which they seemed to work the same in the same way. And so just, different types of dynamics just to see what they would do in the system. And they both behaved the same for both of these. So that was great to see. And then I did see what does it happen in doing a joint. There's also, for robotics, there's also like wheeled vehicles. And seeing like how those interact with a continuous joint, like a wheel. And so yeah, my conclusions at the time were that it does do some things, just as well as classic Gazebo was missing some features, but it kind of depends on whether or not you needed those features, whether or not you should switch over or not. So if you didn't require things like bounce, and if like you basically were looking at, you didn't really require fancy friction configurations, then it was probably a good time to switch over. And that was my initial round of things. I have started looking at the edifice, and so. This is a newer sim I haven't yet posted, so we can run Ignition here with it. Let's see, start. Oops. Oh no, property missing. Oh, it won't work today. That's okay. I'm like in the middle of refactoring. Yeah, I think that's mostly the thing that I don't know if there's any questions people want to ask me on it or anything. I'm here to answer questions.
Thank you, Alison. That was very nice. It's good to see like people trying out the two simulators and checking the different parameters and seeing what's important for their simulation and how they compare. I think it's especially nice that you put out this repository that people can use to test it out and run the simulations by themselves. So that's very cool. We have a raised hand by Thomas Lorente. You want to ask a question?
Did you use the default physics engine for both?
Yeah, I just wanted to see like the defaults to see like, like I just have an SDF. I haven't really set any like special parameters and like which like using different physics engines or whatever, because I think that's a little bit more of an advanced configuration. And so yeah,
Let's do more RNAs to improve things.
Yeah, it's worth pointing out that the default physics engine on Gazebo Classic is ODE, while in Ignition it's Dart. So they're slightly different physics engines. So a lot of the behaviors difference in behaviors may come from that. But yep. Any other questions for Alison? Alison mentioned it during her presentation, but I'd like to point out that a lot of those things have changed since Citadel, and even on Citadel, on latest releases of Citadel, which is something that if people don't know about our release style in Ignition, is that we are always pushing new features and backwards compatible bug fixes to released versions. So even though Citadel was out like over a year ago, we're still pushing new features and fixes to it. So if you use Citadel today, you may get different results, especially like I think friction direction is one of them that is there already, and bounce is also already implemented. So no other questions? Alison, are you planning to do other experiments? Any other specific features that you would like to test out?
Yeah. So, like I said, I started going through to try to update them to Edifice, or like the latest one, just because I do think it's changed quite significantly since I last looked at it. And so I think that I've been looking at. I was looking at things like I think there's a couple tests that I didn't do the first time around that I wanted to also look at. One was torsional friction. I think the thing that stopped me the last time was being able to set an initial velocity easily in it. And so I know Classic Gazebo has a way you can just like set the initial state of a sim. It seemed like the only real way of doing that in Ignition was through a plugin, and I didn't really have the time to make a plugin just to set initial velocities. And so that would be something I would maybe want to look at doing as well. And then I think I did another experiment on, I wanted to see if there was any differences in numerical integration errors, because I don't, if you've ever put like a model inside of a simulator without a controller present, the model will typically like scoot across the ground. And a lot of that is just from like integration errors with the model. But some of it is physics engine related, where you can be like, well, what is zero enough for it to just like not move? Interestingly, like some configurations have worse numerical integration errors than others. So like I looked at like compound joints versus single joints. And it's like compound joints are worse in numerical integration than single joints were, which was interesting. And then as soon as you add like 2 wheels was relatively stable, but like 3 wheels would like move across the the floor. So there was some little like numerical stability things that I wanted to see if like one engine like handled better than another.
Yeah, those would be interesting things to check. Spoiler alert, I can tell you that I'm pretty sure torsional friction is not going to work on Ignition. That was a custom thing that we wrote in Gazebo Classic inside of the fork of OD that we have in Gazebo Classic. So that hasn't been ported to Dart, or now we have support for Bullet in Ignition as well. And I don't think that's going to work there. So implementation for Bullet, and Thomas is doing like quotes. Okay, well, thank you, Alison. If there are no other questions, we can go to the next presentation by Ian. Thank you.
All right, let me share my screen. All right, I think Looks good. All right, let's get started. All right, hi everyone. My name is Ian from Open Robotics. So I've been working on simulation at Open Robotics for the past 8 or 9 years or so. And one of the things that I really enjoy working on is rendering stuff. So today I'm going to talk to you about ignition rendering. So this is going to be a high-level introduction to what ignition rendering is, a little bit of history of how we come about creating this library, what we're working on now, and some of the plans that we have coming up next. So what is ignition rendering? So in ignition, we have a lot of different libraries: ignition rendering, ignition physics, math, common transport, and more. So ignition rendering is the rendering part of the simulation. So it is an abstraction of different rendering engines. So we aim to provide like a common set of high-level APIs that you can use to write, to create a scene, to create content, to render the scene with one engine, and without changing your code, you can switch to a different rendering engine and then would create content using the other engine. So like what Allison showed before, in Gazebo Classic, we have ODE, and we have different physics engines in there: ODE, Dart, Bullet, and SimBody. And now in ignition physics, we have Bullet and Dart. So ignition rendering has the same, basically the same goal as what it's designed to do, to be an abstraction of engines like what we have now, Ogre 1 and Ogre 2, and then we also had, at the beginning, we have optics. So that's what it's designed to do. The goal is very, pretty much very similar to ignition physics, but there are a lot of implementation details that are different. When you look at the code base, you can probably see it's divided into, I would say, 3 main groups of features, of main components. One is rendering, and that's basically using the underlying rendering engines to create content, and that's like lighting, shadows, meshes, textures, asset management, scene graph management, post-processing effects, particle effects, and more. So anything that you would expect a rendering library or rendering engine to do. The other one is sensors, which is probably what differentiates ignition rendering from other rendering libraries out there, is that we provide more tools and classes that's specific to development of robotics applications. So these are things like RGBD cameras, depth cameras, LiDARs, thermal cameras, and more. So this is basically what we are spending quite a bit of time now on. After the initial work will be integrating the core engine, and then we spend all the time working on the sensors. And the last one is visualization. This would be something like visualizing point cloud data, for example, data coming out of sensors, or data coming out of physics engines, like the inertia properties, visualizing the center of mass, joint visuals, and more. So these are the 3 things of what makes up ignition rendering. And what ignition rendering is not it's not a game engine. It is not like Unreal Engine or Unity. You don't have a full editor for you to create the scene. So it's designed to be very simple. It's just API-based library just to do one thing and just to do rendering well. That's what ignition rendering is. So when we started, just a little bit of brief history. When we started out in 2015, it was actually started by an intern we had at Open Robotics. We wanted to create an abstraction of rendering engines. And at the time, we're using Gazebo Classic, and we had Ogre 1. So we thought it wouldn't make sense to have just an abstraction of one engine. We wanted to have an abstraction of different engines. And we picked optics, which is a ray tracing engine. So we can make APIs that work for 2 very different types of engines. If we can make it work well, I think we're heading in the right direction. So that's what we did. Just a little video of what we showed before. This is just rendering an ogre scene. So it's rendering well at 60 frames per second, showing the different shapes and features as supported, shadows, lights, and then here we switch to optics, and you see the frame rate dropping immediately to roughly 10 frames per second. And then we switch back on the fly. What you're seeing there is just seamless transition from one engine to the others. So this is actually one of the very first goals we had. We wanted to be able to switch rendering engines on the fly. So imagine you're doing simulation, you want to focus all your resources on physics, you do a game-like rendering graphics, and then when you want to test your computer vision algorithm, you want really photorealistic rendering, you can switch to a ray tracing engine. So here we go, just showing what you normally see in the ray tracing engines, lots of reflections to make things more visually impressive. And this one. And yeah, so this is just a little history of how we started. And here just showing different types of shadows. You see, yeah, soft shadows, and that we could do with optics. And that's how we get started. So optics right now is needs a little bit more love. We're focusing more our effort on Ogre-based engines, so especially Ogre 2. I'll talk about that later. Let's see. All right, so let's focus on the first part, rendering. So also going back a little bit back to Gazebo Classic, so continuing the trend of comparing Gazebo Classic to Ignition. So you can see on the left here is actually an image generated by Gazebo Classic, and that's using Ogre 1. And this is from the DARPA Robotic Challenge Day. So this is from 2013. This is Gazebo 1, I believe, 1.9. And it's using Ogre 1.7 or 0.4 or something. So you can see that it's the rendering. It's okay. It's not the most realistic thing that you can see. It's very cartoony, as that's one of the most probably one of the most criticisms we have is just rendering quality of Gazebo. You can see the back walls here are pretty flat. Color shading. We have same goes for the ground here, and then we have a road lane here. It's got texture map onto it, but it doesn't receive shadows, so there's a bug. And then if you look at the robot, Atlas robot here from Boston Dynamics and the Polaris Ranger, they all look like they're made out of the same material. So there's no differences in the shading method. So. But if you look at top right, this is also simulated by Gazebo Classic using the same render engine Ogre. So you can see that there is some noticeable difference or improvement in the rendering quality. So this is a project we did with NASA Ames on a simulation of their lunar rover. So this is a rendering of the surface of the moon. So why is it that we have the same render engine? We're also using Gazebo. Why is it that we can produce quality rendering output on the top right, and why it's so different on the left? The answer is actually pretty simple. For the top right, we actually spent a lot of effort writing our own shaders. We bypass a lot of what Ogre provides out of the box. We're using our own custom shading model. So the NASA folks have this what's called the Hapkey shading model, which is specific to lunar surface. And then we're using very high fidelity digital elevation map to create this terrain here. We add on post-processing effect for the lens flare to make this really nice quality output. And there's a Roscon talk on this called Gazebo Renders Moon that shows you how we create a scene. So after this project, throughout this project, we know that the rendering engine that we have is capable of creating quality output, but it just doesn't have a lot of features out of the box. It's just not, we don't really expect robot developers to have so much time, spending months just creating content. Looking forward to our last release, Edifice, you can see here's the output rendered by Ogre 2. So we arrived at Ogre 2 instead of using Ogre 1 to provide more modern rendering techniques out of the box. So here's a demo of what we showed there. I'll show more later. So one of the more modern rendering techniques is physically based rendering. It's more of a concept, actually, as opposed to the traditional fawn-based shading, which uses ambient, diffuse, and specular, which don't really correspond to any physical properties of the object. and you have physically based rendering, which more accurately model the materials or properties and interaction with light. It has more maps here that you can use to create an object. And I would encourage you to also take a look at on the presentation we have from our lead technical artist, Cole, also presented at Roscon. It's titled How to Achieve Realistic Visuals in Ignition Gazebo. It shows you our typical workflow that we go through to create nice visuals and PBR ready assets like this one, including the use of photogrammetry to create high quality models. So just quickly looking at the fire extinguisher, it has 1, 2, 3, 4, 5 maps. The albedo, normal maps, then they have the new PBR maps, the metalness and roughness maps to determine how metallic an object is and how rough or shiny things are. So you can see that the metal part is shinier than the rubber and plastic parts of the body. So you have different material properties in a single object. And we also added a nice touch, this environment map down here, which is a cube map with 6 faces. You can see the reflections in the middle, which is reflecting off of this face here, the 5th face here. So it's a nice touch to create a realistic look. We also have an emissive map and light maps, which I'll show next. It's just another example of not just using PBR to create objects, but also creating the environment as well. So here's a more of a tunnel environment. I shine a bright light into the scene, and you can see how different surfaces reflect light. And on the right, we showed this during our edifice demo presentation. This is an indoor environment. There are actually no lights in this environment. The ceilings are done with emissive maps. And like the shaded area and the corners there, they're all done with light maps. So we use a third-party modeling tool like Blender, and we'll create the scene. And we have direct light, indirect light, and we baked all these lighting information into a texture, and we map it onto here. So it's a more computationally efficient way to create a realistic scene without adding lots of dynamic lights. One of our 3D artists, Rafi, has a nice tutorial showing how to create light maps in Blender. All right, this is pretty recent. So this is one of the recent work that we're doing now for Hyundai. So this is the outdoor environment that we use basically the same workflow that we use PBR maps. And here you're looking at, we also have a external directional light casting shadows. And what you're looking at here is typically for environment of this size, a lot of it is the asset in the end. A lot of it just textures, high risk textures. Yes, that's a skybox and the back end. This is edifice. So looking typically the mesh, the geometry itself, for this one we have roughly 15 megabytes, but we have 20 textures actually. So the rock piles have their own PBR set of textures. The terrain has its own set of textures, and we have different trees. So we end up with like 150 megabyte of textures. So a lot of the quality realistic rendering comes from the high-res textures too. So when you're doing simulation, we always keep an eye on video RAM usage, just to make sure we don't use too much. Because once you use up all your video RAM, including the use of sensors, you start to see slowdown in simulation. But in order to create high quality output, this is typically the workflow and assets that we go through. And there are a lot of nice PBR ready assets on fuel, Ignition fuel. If you're not familiar with it, so this is our website, app.ignitionrobotics.org, and you can search for things like let me see, UGV, and you can see things are created. For example, here's a nice high quality robot created using photogrammetry with PBR ready. You click 3D, you get a nice preview of what it looks like here. very high quality content. If you like it, you can spawn it into Gazebo just to take a look. Here you go. So people can take a look, give it a try, find some nice assets that are already open source, really available on Ignition Fuel. And these are all PBR ready. All right. Let's go back. All right, the next thing is sensors. So let's see how we're doing on time. Okay, we have time. Good. All right, so this is more of a recap of what we have in Ignition. We show quite a bit of it in our Ignition Edifice demo. So here we're showing RGBD camera, depth camera. We have LiDARs. We also rewrote the implementation of 3D LiDAR for Ogre 2. It's more efficient. And then we have thermal cameras. So in comparison to Gazebo Classic, to reach feature parity, we need to bring in wide angle camera and also distortion effects. And then we have feature parity with Gazebo Classic. But there are also new things that we added. RGBD camera is new. The particle effects are new. So you can see that particle effects are affecting depth data that's being, or range data that's produced by these sensors. So there is a parameter called the particle scattering ratio, which is floating point value. If you increase that number, it increases the probability of rays bouncing off of particles or scattered off particles. And to create, you can use that parameter to control how dense or how sparse or less dense the effects are. And for the thermal camera sensor, here you can set uniform temperature for objects, like the simple shapes we have. The brighter the objects, that means the hotter it is. You can also attach heat maps. These are textures created by artists to give some variations of temperature data associated with objects. And if you don't have these heat maps available, Ignition will also generate some variations for you. For example, the backpack and the foam, I believe, they don't have any temperature associated with it, but we still generate some variations, so to give a nice contour. So for image processing algorithms, for example. And what you're seeing here in the image is actually a visualization model that we did in Ignition GUI. So the sensor actually produces just temperature values. And typically in other toolkits, you see something like a purple, orange, yellow type of visualization. We do the normalized grayscale because that was the easy thing to do, but you could add other visualization models to it if you like. All right, and talking about visualization, we had LiDAR visualization. I'm going to show more later that was being added very recently. But before that, I want to just talk about some of the things that we did behind the doors in open robotics. I think every now and then we look at other rendering engines out there. We have a pretty comprehensive spreadsheet with these evaluation criteria to help us look at what the next rendering engine is that we'd like to integrate. These are the requirements are different. Sometimes we get customer requests, sometimes it's project requirements that forces us to take a look at what's out there. And I think coincidentally, we've been doing that, I think, roughly every 6 months or so. And today, we did a lot of prototyping with Godot and Google Filament, for those who are familiar with these two engines. And more recently, we're looking at ray tracing engines. So circling back to ray tracing engines, because everyone has seen all these nice demos from Unreal Engine and NVIDIA. Right? It's hard not to pay attention to ray tracers, especially doing them real time. But today I have time just to show one. I'll show Godot, what we did with Godot. And when we did this test in the office, I posted this image just to show a rendering from Godot and then rendering from Ignition or Ogre 2. So just to see if anyone can tell the difference between the two engines. This is more on the evaluation rendering quality. So if you look at this long enough, you will see some differences. For example, the shadows. One is nice and crisp. One is a bit softer, a little bit fuzzy. If this was 3D, if you rotate the scene around, you see differences in reflections for metallic objects. You can also notice that rescue Randy is noticeably brighter than the one up top. This is actually by design. I'll explain why later. But there are subtle differences between the two. I'll just review the answer here. So the bottom one is Ogre. The top one is Godot. So what we're looking for is like if there's a clear winner or a clear significant improvement of one over the other, but it was difficult for us to judge that. I thought it was pretty good. In terms of rendering quality, I think if we spent enough time on it, we may be able to make this better. But we started doing a little bit of prototyping. We actually spent 3 weeks to a month trying to integrate the rendering engine, Godot into Ogre, and we hit a lot of roadblocks. Actually, there were a lot of integration challenges. Basically, we're trying to shove a game engine, which is Godot, into Ogre, into Ignition, which is rendering library. So we're using Godot in a way that's not intended to be used. And we also had a video call with the main developer of Godot, talking to him about how this could work. And basically, we asked him if we can just rip out the renderer of Godot and use it on its own. And the answer is basically, it's not really what Godot is designed to do. So we decided to pause the effort, and we didn't go forward. Otherwise, Godot is a great game engine. It checks all the check boxes that we have in the spreadsheet. I would use it to create a game myself if I were one day. But unfortunately, that can go forward. We're also looking at other game engines, especially ray tracers. We may have more results to share later on. But all right, let's sum everything up by looking at what we are working on next. So we're trying to get Ogre 2.2 in there. We promised to get into Ignition Edifice, but we didn't. There are some quirks that we had to work out. But we're hoping to get to Fortress, and that's looking very likely. There are a lot of performance and memory improvements. We're working with the Ogre 2 developer. We have an audit Ignition rendering, and now use the Ogre, and it's helping us make several bug fixes, performance and memory improvements, and we're trying to get that into Fortress. I also want to highlight the work that our students are doing for GSOC. So we're doing visualizations. So in the top images there, see initial visualization, center of mass, wireframe joint visuals, and more. And the bottom, we added new sensors. There's a segmentation camera, there's a 2D and also a 3D bounding box camera, which is more specifically focused on machine learning and deep learning applications. So hopefully they will learn in the code base and can get these pull requests merged soon. All right, and that's coming to the end. This is just plans and wish lists. These are things that we want to have integrated into initial rendering in the near future. One is height map for Ogre 2.2. So we have height map integrated from Ogre 1. So that's working already. But we also want to have it working with Ogre 2. And we're looking at global illumination techniques and direct lighting to provide better rendering quality and improving realism. I think this will really help. And we're working with the Ogre 2 developer on this. And then we also want to bring sky with volumetric clouds in back. So what you saw before was a static skybox, but we want to have actual, kind of like sky what we have in Gazebo Classic. But we'll get that in first, and then we're looking at improving that feature. And that's all I have. Thank you. Any questions?
Thank you, Ian. That was really nice. Very complete presentation. Any questions for Ian? Okay, Wellington Castro, your hand is up. You're up.
Okay, can you listen me?
Yes.
Okay.
Yeah, I don't know if it makes sense, but you said that you can change the rendering engine dynamically on the fly. It's possible to use multiple engines at once, like for the camera, use the ray tracing engine, but for other sensors, simpler sensors like LiDAR or depth camera, you can use an engine with less accuracy, maybe.
Yeah, that's definitely possible. We chose to do a transition instead of having them multiple running at once. It's mainly just the limitations of computing hardware. We thought that maybe when two are running at once, it's going to be very expensive. But nowadays, with the improvements in computer graphics engines, or you can even have multiple graphics engines, it is possible. But back in 2015, it wasn't the goal that we started with, but it's definitely possible because we're managing two geo context. So it's just a matter of, I think, minor tweaks to some of the engine management code we have, and we can have them rendering both at once. I think that's possible. It's just not supported right now.
Cool. Any other questions for Ian? Okay, what is your process for designing PBR assets? Benit Shah asked.
All right, so this will be there will be a long answer to this. So let's see. I think there is one person who is better suited to answer this question than me. Is Cole around?
Yes, I'm here. Yeah, I think the best thing to do would be to look at the presentation I gave at RosCon, because it's a little bit too long of an answer to maybe cover here. I'd love to get you the link to that though.
Yeah, so you can see the different maps that we have there. So this is basically Cole used his own 3D modeling tool. He used 3D Max. Other people use Blender. And basically, after you design geometry, there are different maps that you do. And there's some magic that he does that I don't understand, which exports these maps. And then after all that, you import it into Ignition Gazebo by specifying them in SDF. There are SDF specifications that takes albedo map, normal map, middle nose map, and all these maps, and you get a 3D output like this. But as for the asset creation process itself, I highly recommend you to take a look at this here. It also talks about photogrammetry to how to create high fidelity meshes.
Overall, it's very similar to game development asset creation. So as Ian mentioned, creating models in an external 3D software like Blender or 3ds Max, and then creating textures, applying those textures, creating UV maps, that sort of thing. So it's very similar to what you would see in any modern game development studio.
Cole, would you say that you would be able to hire somebody on Fiverr or Upwork to create assets that are compatible, that most artists would understand what you wanted?
Yes, absolutely. I mean, I worked as a contractor for Open Robotics for years doing exactly that while I was working in the game development industry. So yeah, if you're looking for a 3D artist to do that for you, that's definitely an option.
And also there are marketplaces, for example, in Unreal or Unity, that you can just get those assets, and then I think you just have to convert it into, say, Collada format or OBJ format that's supported by Ignition. We're looking to add more support for different formats, but those assets should also be usable too after they're converted to Collada and usable in Ignition.
Yeah, and that's something we've done before for other worlds. Yeah, the Unreal Marketplace is a great resource for that. The Unity Asset Store is great because those resources are already set up for real-time rendering. So, yeah.
Cool. Thank you again for the presentation. Yeah, one thing that I wanted to add that I don't know, I don't remember if you mentioned, is that Ignition Rendering is completely independent of Ignition Gazebo. So it's a library that anyone can use into their own projects, and they don't need to know anything about Gazebo. And we're distributing it for all 3 platforms, Linux, Mac OS, and Windows. So it's readily available to be used by other projects. And also integrating new rendering engines, they're integrated as plugins. So you don't need to change the source code or anything, or even share your rendering engine with us. You can integrate your custom rendering engines in your own projects without sharing that with anyone if you don't want to. Or if you want to share, you can also share. We encourage that. So thank you again, Ian. I'll go quickly to the news. So let me share again. So we have some news here, like we do every month. The Cat curated for us. I wanted to highlight a few of them. There's a lot of cool stuff going on. So one of them is this Ignition navigation tutorial that I found very nice for people who want to use the Nav2 stack with like the ROS2 Nav2 stack. With Ignition, there is like an example set up here that you can use with like sensors and everything. It's using ROS-Foxy, so I encourage you to check it out if you're trying to get started with that. Another one is this support for PX4 on Ignition Gazebo. That's very cool to see that it's working together. So if people are interested in drones, do check that out. And there was another thing that I was gonna bring up. But yeah, lots of good stuff here. The Subterranean Challenge, the finals are happening, and this is all running on Ignition Gazebo Dome. So all of these, the competition and stuff is supported inside Ignition and running on the clouds and all of that good stuff. Okay, so we have 10 minutes or 8 minutes for others, and I have a question down here. I don't know who put it up, but it's a question about spawning a robot into Ignition with a specific joint configuration. I think the question is pretty clear, but whoever asked this, do you want to provide more context before we try to address it?
Yeah, so this is me. Hi guys, I'm Benit. The context is the 0 position for one of the joints has the mesh intersecting with itself. It would be nice to provide like a stow configuration for the robot. So like all the joints are maybe specified. I have seen how to do it in Gazebo, but I also ran into some issues with like, honestly, it was kind of an old GitHub issue. It seemed really old and I couldn't really figure it out. So I was looking to do in Ignition and I couldn't really find any documentation on it, hence the question.
Okay, I can take a stab at answering this, but maybe Adisu or someone else from the physics team.
Yeah, we had, so what you're looking for is not something that's, more conveniently supported. You're probably looking for something like initial position of the joint and just set a value. And we don't have that. And we've been thinking about adding something called a state tag to your model file. So you can just have your model in the 0 configuration and then also have the state of every joint specified. But we have not implemented that yet. That's kind of on the to-do list, long-term to-do list. But a kind of a workaround would be to change your model, but that will, you could change your model so that the link positions are moved around so they don't intersect, but I know that's not a satisfactory answer.
Yeah, thank you, Adisu. If I could, like, I'm pretty new to this, but I would love to help with like a PR or something. Maybe you could point me to the right docs and I can try to take a stab at it.
yeah, the initial work I think we need to do is in fleshing out the SD format spec regarding this. I don't know if it currently has it has like in the state tag, I think it has like link velocity and other properties, but I don't know if it has joint angles. But so we need to flesh that out, and once that's done, we can work on the ignition physics and ignition gazebo side of things. But yeah, just I guess we can. I don't know how to proceed, but if you can create an issue on SD format, we can chat about it there maybe.
Cool. Thanks.
Cool. I was gonna search for an existing issue for this. I think there may be already one, so it's maybe worth looking for one before opening any one. But yeah, otherwise, thank you for offering to open a pull request. We're looking forward to seeing it, seeing the contribution. Anything else that people want to talk about before we leave? Anyone who wants to share something nice about their own projects? Any quick questions? Otherwise, we can call this done. Okay, so just to remind everybody of the Fortress release timeline. If you're a contributor and you're opening pull requests, this is the feature freeze and code freeze dates are especially important for you. And as users, the tutorial party and the community meeting are the dates that you want to keep an eye on. Well, thank you, everyone. See you next month.